Hello, Precalc! Welcome to Chapter 9, Solving Right Triangles. This might be something you did in geometry, because I'm doing it in geometry right now. However, we are, with my geometry class, um, however, we are going to build on it. So this first section, Chapter 9, Section 1, is kind of a recap of geometry, maybe a little more difficult. But then we're going to actually see, you solve right triangles in geometry. In pre-calc, we learn how to solve all triangles. Dun, dun, dun. So let's just recap some stuff here. So sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent, opposite over adjacent. Sound familiar? We covered that earlier this year. I think. I hope. Well, I'm not going to find it. Or in geometry, if not earlier this year, you should have covered that. Cosecant and secant cotangent, you wouldn't have done those in geometry probably. Maybe, I don't know. I'm not doing it with my class, but COVID-19. This makes sense because cosecant is the reciprocal of sine, secant is the reciprocal of cosine, so these are reciprocals. Okay. In the right triangle, the opposite angle is the angle opposite from the opposite side. Sorry, the opposite side is the side opposite from the angle. The adjacent side is the side that is part of that angle. These two lines are what make up, these two rays are what make up the angle. And then the hypotenuse is always opposite the right angle. So the angle that you're using will always be one side hypotenuse and one side adjacent. If you switched it up to here, then this would be adjacent, this would be opposite, okay? So sine of this angle measure will be equal to the value of this side length divided by this side length. That's what that means. So that's a recap of the definition of sine, cosine, and tangent back when we first learned what those were. Now we know them to be so much more, and they've kind of morphed into something so much bigger. But this is actually the original definition of sine, of cosine, and of tangent. And this is always for a right triangle. These only work for right triangles because you don't have a hypotenuse in a non-right triangle. Hypotenuse is the side of it's one side of a right triangle by definition. So what is solving the right triangles? Well, a triangle is considered solved when we know all three side lengths, okay, all three side lengths and all three angle measures. Once we know those, we consider this triangle solved. So we know 6 pieces of information. Now, obviously, we would need to be given some of those 6 pieces to find the other parts of those 6 pieces. And if we're solving a right triangle, well, then one that's given always will be the right angle. We will always know one angle is 90 degrees. Okay, so there's going to be different ways of solving the rest of this. You can't just be given the right angle, though. You need to be given something else. Generally, there's 2 different ways of giving you information that allow you to solve a right triangle. What they could give you, one of them is they could give you 2 sides. We know the angle, the right angle, and then 2 sides. And from those 3 pieces of information, because it's a right angle, we can find the 2 angles and the third side. We can find the third side with a Pythagorean theorem. And then we could find the 2 angles if we're given these 2 sides right here, okay, hypotenuse and adjacent. Well, we would know what adjacent over hypotenuse is, right? We would know what that value is because we know those 2. So we would have cosine theta is equal to some decimal value. Well, most likely it might be nice, but it's usually an irrational number. Well, we could do cosine inverse of both sides to solve for that angle, and once we have that angle, it's just 90 minus 180 minus these 2 angles, or 90 minus this angle will give you the third angle. So hopefully verbally that makes sense what I'm saying here. So if we're given 2 sides, we can find the third with the Pythagorean. We can use inverse trig functions to find the angle, and then just do the fact that these have to add up to 180 to find the other angle. The other thing they could do is give you one of the angles and one of the sides. They could give you any one of these 3 sides and one angle. And again, we would know the 90 degrees. If they gave us one angle, well, that'll be easy to find the other angle. It'll just be 90 minus that. And then once we have one side, we can use a trig function, depending on the side they give us, fill in the angle and fill in the side we know to solve for the third side. And we can do that twice to find, using two different trig functions to find the other side. So I don't know. That's just a verbal. We're going to see this in action in a minute, but that was just verbally going through how to solve that triangle. But the point is that solving a triangle is knowing all three angle measures and all three sides. Solving a right triangle is the same, but you know that one of the angles is right, a right angle. Okay, so let's solve this triangle. Okay, ready for this? In this triangle that I drew, apparently, we have the angle 25 given and the side 40 given. Okay, those are the two angles, or two pieces of information given. So you always need to be given at least three pieces of information. For right triangles, it's going to look like two because the right angle is the third piece of information. We know this right angle, and this right angle allows us to easily find this side B, or angle B, I mean, big capital B, angle B. So we are given three pieces of information. That doesn't mean that any three pieces of information on any triangle allows us to solve it, but we need at least three pieces of information on a triangle to be able to solve it. Okay, doesn't mean it'll always work, but it will. We will at least need that for it to work. I don't know if that's making sense. With a right triangle, as long as we're given two things, it won't work if they gave us, like, for instance, here's what I'm trying to say. We would not be able to solve this triangle if they gave us two angles, and then the right angle and no sides, for instance. So it's not just any two pieces of information. It has to be certain pieces of information. But we will need to at least be given two things on a right triangle because one is the right angle, or three things total if you count the right angle. Okay, so as we see here, we know the angle A is 25. We don't know what angle B is. We'll have to find that. We know that angle C is 90 because that's the right angle. We know that side A is 40. We don't know what side B is. We don't know what side C is. I put an angle in front of the A just to make it a little different, but the angles are capitalized. The sides are lowercase. Very important to be consistent with that when you're typing it up, because if you do a capital B, I'm going to assume angle, even if you don't put the angle symbol. And if you do / angle, it will make that angle symbol, or it will be in Free Math App probably in the geometry drop down. So I'm going to start with, you can actually start, sometimes it might make more sense to start with certain things to help you find other things, there's something else to go into with that. But you can pretty much go in any order, as long as there's not some reason you can't. Does that make sense? So you wouldn't have to start by finding angle B, is what I'm saying. But in this case, I'm going to start by finding angle B. We know that these three angles have to add up to 180, or these two have to add up to 90. So we use that knowledge to find angle B is 65. Pretty easy stuff right there. Hopefully you're not struggling with that pre-calc. So side B. So to find side B, AC, and this is where you could do C or B, whichever one you want to start with. I'm going alphabetically. That's why I'm starting with B. I do the angles first. I don't know if I always do this. I can't promise that, but it seems like this is what I do now, and I can't guarantee that I did this in the notes, but I hope I did. But I usually do the angles first, A, B, and C, and then the sides, A, B, and C, like in order. Now, again, there might be situations where you might need to find something in order to find something else, so it might not always work that way. But for right triangles, that's usually not the case, or really can't be the case. So side B, starting with side B. So I have angle A. I know that. I do now know angle B. I'm probably going to default, if I don't need to use something that I found, I'm going to default going with the stuff that was given. And it's a really important reason why I'm doing that. And let me just make sure I'm doing that. Did I not do that? Okay, so I went either way. And there's a reason. Okay, so there's a reason I'm doing it both ways here. So why am I saying go with what was given rather than what you found? If I would have made an error in what I found here, let's say I did the subtraction wrong and put 55 in here. Simple error, quickly accidentally typed, maybe 80 here instead of 90, or 100 or something. Well, or like 90 here instead of 80. That would have given me 50. No, 70 here instead of 80, whatever. I would have gotten something wrong here. Then I am then using a wrong answer to find more wrong answers. Where if I would have just went with what I found up here, 25, then I wouldn't have that danger. Does that make sense? There's a chance that if I make a mistake in this, then I might be using that to find other things, and it's giving me more wrong answers. Or if I just went with this, then it wouldn't have that problem. Now, it was something like this, I probably didn't worry about that as much because I'm not too worried about the subtraction error here. It's possible that you make a subtraction error, but I'm not as concerned about that. So I actually showed both ways of doing this one, apparently. This is probably just for a variety, just to give you some variety on how to find side B. So going back up to this image, and I'm sorry I'm going to have to scroll back up and down here because, well, actually I could maybe try something real quick. Let me see here. This is just crazy to try. Alright, so now if I drag this here, I won't have to scroll back up and down, I don't think so much. Of course, my picture can't be, my image of the camera image can't be blocking it. Which I've done that in the past accidentally. Okay, so now I don't have to scroll back up and down. Nice, nice. Alright, so to find an angle side B, let me switch back to the hand. So find side B, and if I know A and B, I can do two different things. I could go, and I know side A, so if I know angle A and angle B, there's two different ways I can approach this, knowing side A. Okay, I know side A. So if I'm going to use angle B, which is found to be 65, I will have to do opposite over adjacent. This is the opposite side, this is the adjacent side, so I'm doing this part over here. Okay, well that would be the function tangent. Tangent is opposite over adjacent. Remember at the top here? Opposite over adjacent. Oh, tangent is down here. Opposite over adjacent. So depending on what side is given and what you're looking for is what determines which trig function you're going to use. Okay, so 65 here. Okay, opposite over adjacent. So I fill in the angle measure 65, and then B is what I'm looking for, and 40 is what is known for A. Solve this by multiplying both sides by 40. So tangent of 65. You do want to make sure that you are in degree mode if you're dealing with degrees. And then you do 40 times tan 65, and I get 85.8. Okay, it's okay to do one decimal place for these. I allow that for solving triangles. Just because the numbers are usually bigger, so it's enough because there's 3 digits there. You don't usually have like 0.1 answers. So that is how I found side B using the angle here. But like I said, it'd probably be best if I didn't use 65 just in case I made an error here. So let's go back up to 25. So if I'm using angle 25, the opposite is A, the adjacent is B. Again, tangent, that's tangent. So tangent of angle A is side A over side B. I'm going to fill in 40 for A again, but you see how these are switched because I switched the direction. And but I need to put 25 in for this. Okay. To solve this for B, you can swap the tan and the B. Okay, because if you think about it, multiply both sides by B. So you have B times tan equals 40, and then you divide both sides by tan 25. Tan 25 is just a decimal number, so you can divide both sides by it. And so 40, oops, make sure it gets to 0, divided by tan 25 is the same thing. Okay, so now I have A and B. Okay, so how did I find C? Well, I just wanted to make sure I didn't do this the way I'm going to suggest here, not that you don't do. Both of these were rounded. I did the approximately equal to, so make sure you do type that /APPROX when you do this. So I now know two sides of a right triangle, and I could use Pythagorean theorem to find the third side. And if I had no other option, I had no other way of solving this, finding the third side, then I would say do that, okay? But there are other options, and I'm going to not only, again, go back to, well, what if I made a mistake here? Well, I don't want to use this side when trying to find another answer, and then have a mistake number obviously would give me a mistake inside C. But there's also another reason I don't want to use this, and that's because it's approximated. So once this is approximated, now I have a rounded number, and if I can solve for side C using something that's not approximated, then I will get a more exact answer. Because once I use an approximated number to try and find something else, that's also going to be probably going to be approximated. I'm just now throwing the error off more, the approximation off the actual value more. Does that make sense? I mean, hopefully that makes sense, I should say. So I'm taking an approximated number and I'm plugging into other things, and since it's not exact, it's going to be off by even more than it would be if I used exact values. So instead of using B and using the Pythagorean theorem, which some people might suggest at this point, I'm going to go back to the trig functions, because I know A, I can use A, and I want to find C. Okay, so if I'm going from angle A, if I'm looking at this from angle A, this is opposite and this is a hypotenuse. Well, up here there's an opposite and a hypotenuse that uses the trig function sine, so that's the trig function I want to use. Okay, so sine of the 25 degrees is equal to 40 over C. Okay, solving this for C, you get C is equal to 40 divided by sine of 25. You plug that in the calculator and you should get 94.6. Also, if you did it with the 65 here, then it would be opposite. Sorry, A is adjacent. A is what we're not looking for B anymore. A is adjacent. Okay. C is hypotenuse. So we're going to use the function cosine in this case. Okay. Switching the side here. Okay. So this is what we know, and now it's adjacent. So it's cosine of 65 degrees is equal to 40 over C. Solving this for C would be C equals 40 divided by 65. You get the same thing both ways. I don't think I need to put that in the calculator again. So now we know all 6 pieces of information, all 3 angles, and all 3 sides. Okay, hopefully that makes sense. So sometimes they might not write out a picture. They might not draw a picture. Wait, give me a second here. Let me see something. Yeah, they did. I drew a picture here for example 1, but sometimes they might just say solve the right triangle with A equal to 50 and B equal to 30. Or they might say legs, that has the legs 50 and 30. Now, A and B are always the legs of the right triangle, and C is the hypotenuse because of the Pythagorean theorem, A squared plus B squared equals C squared. So they could say, we can assume that A is a leg and B is a leg. And if they would have said C equals something, we'll assume that's the hypotenuse. Probably maybe the best thing to do would be to draw a picture if they don't give you a picture. So here's my picture of this right triangle. So they gave us 3 pieces of information, by the way. They gave us a side. They gave us a side. The third piece of information is the fact that it's a right triangle, and that gives us the right angle. Okay, so we don't know angle A, we don't have. Angle B, we don't have. We don't have side C. Those are the 3 pieces of information we're looking for. Now, to find an angle when given 2 sides like this, we're going to start with A. Like I said, I start alphabetically. A, angle A. Really, you could start however you want, but I'm going to start with angle A. So A here has side opposite and side adjacent. Opposite and adjacent are the 2 things given. So that would be the trig function tangent. Okay. Tan A is equal to opposite over adjacent. So 50 divided by 3 is 5/3. To solve this for the angle, we're going to do tan inverse. So I'll show you with the calculator on this one. There it is. How to do this. Again, we want to be in degrees. Second tan 5 divided by 3. tan inverse. So I got 59.0 because it isn't exactly 59. So I like to put the 0 because it's a rounded number, and if you don't put a point, it doesn't look like it's rounded, but it's a solid integer. So yeah, so that's the angle measure of A. Okay. Now, I know I just suggested that you don't use rounded answers and given answers to solve for B, but there is, and I do allow. It's okay. It's not as bad if you're just subtracting. All we're doing here is subtracting. That's the only operation we're doing, and subtraction is pretty much the easiest operation. So it's not multiplying. It's not plugging into a trig function. It's not taking the square root of. It's not squaring. So that's why I allowed it for angle measures here. Hopefully that's not confusing. And again, there is the danger of accidentally finding the wrong thing here, typing in wrong, and then getting the wrong answer here. So it would probably be better if I did the trig function again, just to make sure, and then I can double check by looking to make sure these add up to 90. But that's not how I did these notes. If I were rewriting these notes today, that's what I would do. That's not how I did these notes years ago. But since it's just subtraction, it's a little bit less. I'm a little less worried about that, if that makes sense. Finding C, okay? Finding C. Now that we know these two angle measures, you might be tempted to do the trig functions, use trig functions. This is where I would not advise you at all to use trig functions to find C. So like, for instance, I know this angle A is 59, approximately 59 degrees. Opposite over hypotenuse is sine. Do not do sine of 59 equals 50 over unknown because of the fact you're using a rounded answer here. Instead, we're going to use the Pythagorean theorem, and you use two values that we know to be exact, okay, and that we didn't find to find C. Okay, so you're going to just use the Pythagorean theorem to find C here. And go through the process of the Pythagorean theorem to find the third side. And like I said, you could have found this first and then did these, but I like to do angles first in alphabetical order, sides second, and then sides in alphabetical order. It's just the order I do them in. There will be more complicated problems in the future where you will be forced to solve in certain ways because we will be forced to use rounded numbers, but that's only because that we just found, because that's the only way to continue. But with the right triangles, that's not the case, okay? I think I'll break this up into two videos, but there is a second part to this section that I'm going to do with this one. I'm going to release these both in the same day. So thank you and good day for now.